Okay, so in this chapter we're going to be looking at linear inequalities. And linear inequalities is pretty much the same as just regular equations, except instead of equal signs, we deal with less than or equal to signs, less than signs, greater than or equal to signs, and greater than signs. And as we progress, you'll start to notice how graphs behave differently when we have these signs instead of just an equal sign. So let's start by looking at this word problem. You have an allowance of 40 food pellets per day. If adult penguins eat 4 pellets per day and baby penguins eat 2 per day, how many of each can you have? Now, we'll notice here that there isn't just one solution to this question. There are many, or even an infinite number of solutions if you could have fractions of a penguin, but you can't, and if you could, that's morbid. So let's just start by writing this out as an equation. We have 40 equals, now wait, there's more than one solution, so let's try writing it as we have 40 food pellets, and we can't have any more than 40 food pellets, but we can have 40 food pellets, and we have 4 penguins. Let's see, adult penguins are eating 4 food pellets, plus baby penguins. The number of baby penguins are eating 2 food pellets. And you'll see that this equation makes it so that we can't have a combination of adult and baby penguins that would eat more than our allowance of 40 food pellets. So now how do we graph this? Well, the simplest way to do this is to convert it into a y equals mx plus b form, which looks just like this, where m is our slope and b is our y-intercept. So to do this, let's just get rid of this inequality sign, and we'll deal with it later, and set it to 40 equals 4a plus 2b. We'll say b is our y value. In this case, it really doesn't matter because we don't really have an independent or dependent variable. So we'll subtract 2b from both sides, and we'll also subtract 40 from both sides, which will leave us with negative 2b equals 4a minus 40. Then we'll divide out the negative 2, and we'll find that we have b equals negative 2a plus 40. And now we have it in a y plus mx, or y equals mx plus b form, and we can just graph it out. So here's our graph. I'm just going to do a rough sketch here, because you should all know how to graph straight lines at this point. So our line goes through 40, so we're up 40, and we have a negative 2 over 1 slope. So we'll move over 1, down 2, over 1, down 2, over 1, down 2, over 1, down 2, and we'll find that we get a line that looks something like this. So here's our line, but and all of these numbers are possible solutions, but there's more than one solution at one point. So how do we do that? Well, now we can look back at our original equation where 40 is greater than or equal to 4a plus 2b, and we can pick a test point to see which region of this graph satisfies the equation. Now, if you can, it's always best to pick 0, 0 because it's the easiest to use. So we plug in 0 for a and 0 for b, and 4 times 0 plus 2 times 0 is just 0, and we find that 40 is greater than or equal to 0. So now we know that this whole region here, which we'll just shade in, is a solution to our system. So now we've solved it, and it's as simple as that to solve a linear inequality. Just keep in mind that if you have a greater than or less than or equal to sign, you will draw a solid line, but if you only have a greater than or less than sign, not an equal to sign, you would draw a dashed line to show that your solution set is not including this area here. So now we're going to look at dealing with quadratic inequalities, but only one variable to start. So instead of having to deal with a y and an x-axis, we really only have to worry about the x-axis. So let's say we're given the exciting problem where a car goes off a jump and follows the line y equals -1 over 4 times x minus 4 squared plus 10, where y is the vertical height and x is the distance of the car from the jump. Where can you safely put 7-meter high flames? Pretty cool, right? So here I've drawn out the shape, the arc that the car forms when it goes off the jump 6 meters high, and here I've drawn a line 7 meters high. So we know that this is the area where we can put sweet flames and we won't burn the car. So to solve, we basically want to find the roots of the equation along the value of 7 on the y-axis. So I've written this out, but this isn't complete because it's not just 1 or 2 points that we're solving for. We're solving for all the points in between here. So what we'll do is we'll use an inequality sign. So we can say that 7 is less than or equal to -1 over 4 x minus 4 squared plus 10. And that way, that the height of the car will always be greater than 7. Now, I should note here that it can't actually be equal to the height, because if the car was the same height as the flames, you would have a burning car and a very sad daredevil. So there's our inequality equation. Now let's solve it. So we'll subtract 10 from both sides, and we'll solve just as if this was just an equal sign, just to make things simple. So we subtract 10 from both sides, and we find that we have -3, divide out our -1 over 4, and -3 divided by 0.25 is equal to x minus 4 squared. The root of 12 equals x minus 4. And note that because we are square rooting a squared value, this number here can have positive or negative values. So we find that positive or negative, the root of 12 plus 4 is equal to x. So just to avoid decimals, this is how we will write our solution. Now, this doesn't really give us quite enough information, so how we'll do this is we'll say we know that the negative root of 12 plus 4 will be the smaller number right here. So we can write as negative the root of 12 plus 4, and we'll say that x is larger than this value, but x is less than the positive root of 12 plus 4. And this is our solution, and we can write it just as if we were to write a domain. So we'll have x such that x is larger and smaller and fits into this area, and x contains elements of all real numbers. And that is how we solve a quadratic inequality with one variable. But what about solving quadratic inequalities with 2 variables? Well, let's say we want to hang a car from a crane. Another cool stunt. Given the equation m equals less than or equal to 200d squared plus 10, where m is the mass in kilograms of the car and d is the diameter of the rope, show all possible combinations of the car weight and the rope diameter. So to start, let's graph it out. Now, sometimes you'll be given an equation in general form, but in this case we're lucky because we can see that this is already in vertex form. Maybe putting those brackets there will just help you get your mind around it. But we have our a value, which is 200. We don't have a p value, so we know that it will be on the 0 on the x-axis. But we do have a q value, so we know that our vertex point is up 10 and just on the 0 axis. Now, we have a pretty steep slope of 200. So we're just gonna, for this sake, I'll purely just sketch it out, since we don't need to use the graph to really solve for any values. So I've sketched out our parabola. Notice that it's a solid line because it's less than or equal to, not a dotted line. And Now we need to find which region, if it's inside the parabola or outside the parabola, that is the solution region. Now, just like when we were solving a linear inequality, we can pick a test point. Generally, the easiest test point to pick is 0, 0, because most of the time our variables' coefficients just cancel out and it becomes really, really easy. So we know that m is equal to 0. 200 times 0 squared plus 10, and it just simplifies to 0 is less than or equal to 10. Now we know that this test point here satisfies the equation, so we know that it will be this region in here that is all the possible values of the mass and the diameter of the rope. But we can't really have a negative diameter of rope or a negative mass of the car, so we're going to set our domain and range. So we know that our y value, our m, we have m such that m is larger than or equal to 0, and m contains elements of all real numbers. And we will just write out, and we'll also say that d such that d is larger than or equal to 0, and d contains elements of all real numbers. And that way we're restricted purely to this positive quadrant. So we can only have a positive mass and a positive diameter, which makes sense unless you have a car full of helium. So there's our domain and range. We have our inequality here, and we have our graph. It's as simple as that to solve a quadratic inequality with two variables.